I'm making the assumption that this posted problem was supposed to have a slash symbol here, and somehow Wyzant didn't accept the slash. So here's the function. It's called a rational function because we have a polynomial divided by another polynomial. Question number one asks, what is the domain of the function? And the key is, for rational functions, you cannot divide by 0. So the numbers that we're not allowed to put in for x are numbers that make the denominator equal to 0. So if x minus 6 equals 0, then x equals 6. So when x equals 6, the function is not defined. So the domain is all real numbers except 6. And you can use interval notation or set builder notation to specify that domain. For problem number, or section number 2, the x-intercepts occur when y equals 0. See if I can move this out of the way here. Yeah, there we go. So if I set the function equal to 0 and solve for x, I could multiply both sides by x minus 6, which would just give me x plus 12 equals 0. Another way to think about it is that the x-intercepts occur when the numerator is equal to 0. The denominator has nothing to do with it. So if x plus 12 equals 0, x equals negative 12. So the only x-intercept is at negative 12, comma 0. The y-intercepts occur when x equals 0. So if I put 0 in for x, I get 12 over negative 6 or negative 2. So the y-intercept is located at 0, comma negative 2. Vertical asymptotes are vertical lines. They happen when the denominator of the rational function is equal to 0. A rational function can never intersect or cross a vertical asymptote. As x gets close to the value of its vertical asymptote, the y value approaches negative infinity or positive infinity. So this denominator equals 0 when x equals 6. That's your vertical asymptote, the line x equals 6. On board 2, we'll talk about horizontal asymptote for a second. There's actually 3 separate rules for this. But if you have a rational function, the key is understanding, this says show the steps you took to find it. These are the steps you would probably go through. If you divide every term in the numerator and denominator by the highest degree term, you get something that looks like this. I divided every term by x. And what you need to understand is if you have something like this, a constant over x, even x raised to a power, where c is a constant, as x gets bigger and bigger, then the y value approaches 0. So if you picture the function rewritten this way, as x gets bigger and bigger, these terms approach 0. And so the y value gets closer and closer to 1. And the shortcut for realizing that is that the degree of the numerator equals the degree of the denominator, then the coefficients of those highest degree terms determine the horizontal asymptote. Okay, so y equals 1 is the horizontal asymptote for this problem. It's possible for a rational function to intersect its horizontal asymptote. To determine if it does, you set the function equal to the y value of the horizontal asymptote and solve for x. But in this case, these x's cancel out. You get, well, actually, I should say plus 12 does not equal negative 6. So this particular rational function does not cross its horizontal asymptote. So how do you sketch the function? Well, here's an x and y coordinate system. These green dashed lines are the horizontal asymptote and the vertical asymptote. Sketch those in. And for this particular problem, the graph can never cross either of those dashed lines. So here I've plotted the y-intercept at 0, negative 2, the x-intercept at negative 12, comma 0. As x approaches negative infinity, we get closer and closer to the horizontal asymptote. So this blue line is going to get closer and closer to that green dashed line. It's never going to touch it. So we can sketch the curve like this. We'll take a look at this table in a second. Over here, we'd have to plot some particular points to see how the graph goes. For example, when x equals 6.1, we get something close to 18 in the numerator, and we get a positive number in the denominator. That's supposed to be a 0.1, which is 180. So it's way up here when you're just past 6. So that means the graph has to go like this, getting closer and closer to its horizontal asymptote this way. And you could plot some points in here. 10, 5.5, I think I plotted that point right there. And here's what it looks like on Desmos. There's the x-intercept, the y-intercept, horizontal asymptote, vertical asymptote. And this table right here kind of confirms what happens as x approaches negative infinity. The y value gets very close to 1. And as x approaches positive infinity, the y value gets very close to 1. One of them happens to be below the horizontal asymptote, one of them above. And as x gets close to its vertical asymptote, like 5.999, look what happens to the y value, negative infinity. That's why this is going down this way. And if we're close to the vertical asymptote from just to the right, 6.01, we're at 1800, way up here. And here's a specific point right here, 15,3. That'll help you draw a sketch. Okay, there you go. Hope that helped. If you have any questions, post a comment.